Hello and welcome to a new conversation on the Hitchhiker's Guide to the Glamorous World. And I'm joined here today by Michael. Michael recorded a live streaming session about working with Glamorous Toolkit. And this is basically a follow-up of that. It was very interesting to see how you're navigating and how you explained live, what you were seeing in front of you, and so it was very educative, educative also for me to
It's,
learn.
it's always interesting to see how people misuse your software.
It's
You
not
have.
just, it isn't misusing, but we are still learning. We're still learning to explain what it is that we're doing, right? So the interface that you see in front of you is essentially our attempt to decompose how we think about this idea of multiple development and how programming could and should look like. But it's still, I think, I'm very convinced that there's still a long path ahead of us. So all of these interactions are actually very, very useful. On both ends. But I'm very interested because you said that you took a look at Glamorous Toolkit about a couple of years ago, played with it a bit, and then you went and did something else, and then came back to it now. And my question is, why did you choose to come back to it?
Well, okay, so it wasn't really that like I saw this and oh, it's terrible or anything like that. It was more like basically 2 years ago I really made the decision to really work on computer science videos. I want to make a YouTube channel about that. And I was looking for a tool to animate and visualize algorithms and things like that. And I had a lot of time on my hands because I was on paternity leave and I had a newborn. And so I had some time off and I was really able to spend a lot of time, like, I was up all night in the middle of the night with the sleeping baby, and then she would wake up and want milk. So I was on the night shift and I had like a lot of time to work on this stuff. And then she got a little bit bigger, and for the past 2 years, I just haven't had a lot of time to do anything. So it was more like just picking up where I left off.
Nice.
I've been working on like a presentation tool, but I'm really still missing the animation part. And and also I keep running into I work on this Rust thing, which is some part of what I want to present that has something to do with like binary Boolean expressions. And I'm always working on these algorithms, and then I feel like, man, I'm dealing with these giant graph structures. I wish I could visualize them. So that's also another reason why I came back. And then in particular, I saw that you were. I discovered very recently that you had started integrating Rust into Glamorous Toolkit, and so I was like, oh well, let's check that out. So that's what motivated.
Incentives. Nice. Right. But also 2 years ago, it was probably usable, but not in the same way as it is today. So yeah, great. So what I suggest is during the recording, I noticed a few things that perhaps could be improved, not so much in how you're using Glamorous Toolkit, but maybe how you formulate, or digest what you see in front of you.
Okay.
So, and I think would be an interesting point, a starting point would be to simply just go back to where your project is and maybe put a little structure into the vocabulary you use to describe. And I'll explain afterwards why I think that is important.
Okay. Maybe I should share my screen here.
Yes.
My Zoom window is not going where I want it to go. Okay. So I would say right off the bat, I'm not sure that like I keep any kind of like persistent state. Like I haven't really started using the image like to its full potential. So I'm not sure that I even saved anything that I worked on. So
we can take it from scratch if you want.
Okay. So I think, yeah, so I didn't even add my repo here. So I said load a local repository, and then that would be on the D drive.
Yes. And you have this ver, yes.
Yeah, I remember. And then, so Oh,
Go
okay.
ahead.
So I had two things. One was the main thing was Ganges
Yes.
Storm Pharaoh. So all right. So that's what I have. I think I clicked. All right, that all worked. Okay.
Yes. So.
And then I have right. Yeah. So I had made this little. This is basically a visualizer for a log file that I don't even generate anymore. So,
I see.
but it has a little parser in it for that thing, and I was just kind of experimenting with the. I guess I have to load this.
Yeah, if you load it, then you'll have the code in the image. So now you've just loaded the repository in the Git tool. So you simply just registered it, but it's not affecting the image until you load the code. So now you've just compiled the code and you'll have the
Okay.
classes and methods available. Now, just for this one here, so how would you, what's a different way to do exactly what you've done, but basically more automatic? You don't want to click your way too much of this. So there's a, you would like to use something called Metacello, which is a configuration management system, which basically says, this is my project. It's consisting of these packages, maybe depends on these other projects. And then you just load it with one single instruction.
To prepare for this, I watched all the 7-minute videos and I saw Oscar's talk on setting up a GitHub repo. So I just haven't done it.
Yeah.
Okay, so that,
right. And once you're doing that, then you will start to, you basically have a page in your own private Lipitor database, which would say load TS file, for example. And that will just have your Metacello instruction. You basically just open that page, execute the snippet, and you're done, essentially. So that's like the flow. And then at the end of it, when you're modifying your code, you want to come back to this tool and says, I want to commit and potentially push, but in your case, it's just a local repository.
Right. So, and when I've changed something, it will show like you've changed this over here.
Exactly. You will have there will be a new tab with changes.
Oh, okay.
And you will have the possibility to commit. So right there, where you see README, commits, packages, examples.
It changes it.
Yes, and you'll be able to commit from there. Okay, but yeah, so let's take something that you would like to take a look at. So for example, last time, one of the things where I saw you had a little difficulty finding your way was when you were looking for examples, and about the meaning of what is an example exactly. And although you summarized what an example is, you said tested return objects, basically, like tests, right? But somehow there was a little bit of a confusion as to, when do I look for it? Where do I look for it? What does it mean when I see something?
Well, I mean, like from right here, I couldn't tell you how to get to my code. Like I know I can search for like Bex in the spotter, but like I would think I should be able to like I don't know, repository directory maybe.
No.
Examples?
So here, wait. So the question is, what are these views that you see in front of you? Because then you see that, in our image, we have several thousand such views. So if you learn the views as like you would learn features, there's a lot of stuff to learn. And that's why Glamorous Toolkit is not conceived like that. It's more, you learn Glamorous Toolkit more like a language, not like a set of features. So, if you look any other development environment, right, the menus are fixed, the amount of buttons are fixed, the shortcuts are kind of fixed. It's something you'll learn. Here, everything, because we want to go from the idea that everything deserves to be interacted with in a contextual form, it follows that we'll have orders of magnitude more such context, orders of magnitude more little things. So it doesn't scale to remember all of those. So instead, we think of Glamorous Toolkit as a language made of visual interactive operators that you can combine in many, many ways. But so the discoverability is also kind of important. So at this moment, right, we see, you will see these tabs appear quite everywhere, right? In Coder, you have tabs. In Inspector, you have tabs. Here, you have tabs. So what is that tab? what does it mean? Before you're going to use something like that, you want to have the question, so what does this mean? So could you please press Alt-click on the tab name?
Okay.
Okay. So what you see now, this is the definition of the view. In fact, it turns out that this tab here is like an inspector definition, but it also appears in an extra tool. So you see in the top here, right? This is a GT view here. Then it's also annotated with GT repository view. And that's because this thing here on the left is nothing but a kind of more elaborate inspector. So it's not an inspector. We think of an inspector as a tool. Coder is a tool, and so is this Git repository tool a tool. And notice, for example, here there's an I. If you click on that, you switch the tool here. So here, obviously, the most basic tool anywhere in the image is the inspector. So many things that you find in the higher level tools, you will find also in the low level tools, in the lowest level tool, which is the inspector. So here we have an inspector over the Git repositories, and then of course you have all sorts of other types of things that might or might not be interesting for when you're doing the something that you want to have more streamlined. Like the first thing, you don't want people to see this as being the first thing. This tool, and that's why we have this other one, which is just optimizing for certain kinds of patterns. But that isn't to say.
What did this actually do though? Like what? So what am I looking at here, and what am I looking at here? What is the difference between these two?
The difference is that they are different tools about the same thing.
Okay.
A tool is so the whole idea of multiple development comes from the realization that you cannot interact with anything in a software system except through tools.
Okay.
You cannot perceive anything in a system except through the intermediation of a tool, which means that the tools are essential. And we said, well, until now, we've considered tools were just like transparent. We just consider them to be the same, and we use the same tool across any context we've ever seen, right? And then here we're saying, actually, and there's a great deal of which tools you're going to look at the problem through. Yeah. And so what you have here is you have lots of little operators that allow you to construct and customize tools depending on the context that you're looking at. So the most basic of all tools is the inspector, an inspector over an object. That's the most basic thing. And an inspector has views, right? And these are these methods, annotated with GT view here, right? And this will appear in an inspector over an instance of this class, right? This method, GT examples 4, is defined in GT Git repository. That's a class. And whenever we're going to have an inspector over an instance of GT Git repository, we will be seeing a GT examples for a view defined in GT examples 4. So it will be called examples. So if you switch back now to the inspector.
Now, so this is like, first I'm looking at a view that the GT Git repository is like, it's like showing what it's all dressed up. It's showing it what it wants to do, like what it wants to look like. And here I'm looking at just like take an X-ray and show me the actual object as if it were just a small stock piece.
That's the plumbing, right? That's where this whole thing is. A tool is more of a, I noticed that I'm doing this very, very often. So I don't want all this baggage here. And for example, especially for newcomers, but also when you just want to be noticed that you're doing the same thing over and over, then you want to optimize that.
Yeah.
But this doesn't mean that every once in a while you might want to do something else, and you always go back to the underlying level, and then you have access to everything, including programmability.
Gotcha. Okay.
Right? So this view over here comes from this method over here. Right? It's in the inspector. Okay, good. So, but now, what is a tool? What is a higher level tool? Well, it's just basically picking up some of these views and assembling them in a slightly better, in a better presentation. So that's what this other tool is. It's exactly the same thing, but assembled slightly differently than the inspector is. So when you flip to go back to the package view, right? So now we have this. So now what does this mean, right? And you were saying, okay, I now would like to go and find my packages, the code that I have just loaded. And maybe it's already possible with this tool, but if it isn't possible with this tool, the whole idea is that you have the right to be able to create exactly what you want to have. So maybe if this view doesn't exist, or if the interaction doesn't exist, you should be able to actually add it. Now, in this case, probably try selecting something here, right? And it actually opened something on the right. Because every time you
did that happen
with
before
something,
though?
it did.
I think,
Yeah, this is actually how you found your code first time, I think. You
so I double clicked on it and opened this thing,
yes,
and then but without that view
yes,
visible, then it doesn't. Then you don't see it. Okay,
yeah,
that's what was throwing me
right,
off.
yeah.
Got it.
So
Okay.
now let's maximize this one just briefly, just so that you see also these other different the one on the left.
This right. Okay.
Yes. So this is what you saw the first time, right?
Right.
That's where you are. Okay. Now you have the pane always exists, and you're always in something we call a flow. Only spelled PHLOW. That's a low-level library. And so the idea is that you have a flow of investigation, and we want to have we want to reify that investigation so that you can keep track of the steps that you took in the underlying interaction model. So from here, right, when you zoom in, I just want to look at exactly this one. You also notice that I have this kind of global coordinates. That is, I have all the list of repositories regardless how I got here. Okay, but now I say I want to go and I want to spawn it to the right. If there exists a pane to the right, then it will automatically populate it just with one click. If it doesn't, you can force create the creation of a thing to the right by double click, right? And then once this exists, then just select a single selection works.
Oh, I see. This one isn't loaded, so I just get like knowledge about.
And then of course,
text
notice how that little thing, this load button, is actually was here. If you select that,
oh, I see. Yeah, okay.
It's the same because it's the same thing. It's not that. Right, so if I inspect this and you say, well, yeah, but this is so complicated. So why is this in need? It's needed because our goal is to explain anything in the system. Now, to explain anything, you have to explain the smallest thing. That is, if I'm just looking at some little piece in isolation, I have to be able to do something meaningful about it. So I want to take, ideally, and this actually relates to your goal of explaining, for example, structures and algorithms. So when I take a piece out in isolation, very often I would like at least maybe to say, oh, what can I do with you? What kind of views can I have with you? But also sometimes I want to see it, oh, where am I in a larger context sometimes? Mm-hmm. Let's say if I have a map, I have a node in my abstract syntax tree, I would like to see myself in that place, or I have a node in the abstract syntax tree. I would like to see where this node is in the source code, so highlighted over the overall source code where I am, right? And then all of a sudden, it means that little thing has much more context. It's much more explainable. But once you can do that, then you can start to assemble little, those you have these little, you can think of those like bits and pieces out of which you can construct larger representations. And this is why in GT itself, there are literally thousands of extensions. The core technology comes with extensions, because extensions is not just for users. And I'm not going to have, and we don't know how to enumerate. I can't tell you from the top of my head how many plugins, which plugins do I have, because I just have too many. So when I'm going to work on a new system, I might have hundreds or thousands more, because it comes with some context. And just think of the other thing, right? You'd say, you found your example. So, and then also here, right, in the Git repository, one entry point are packages, but another entry point are actually examples. Right? Because why? Because the examples is what got you quickly to say, oh, I actually have this view. You remember?
Yeah.
You found the view and I said, oh, I built that. Right. And the interesting thing about it is that you clearly forgot that you have built it.
Yeah.
So you have it in you built it in your server, right? Because you had that idea with you. You just forgot that it was here. But once you saw it, it triggered, you remember what it was. And that's the interesting bit here, right? Is that you can document for your future self or for somebody else what somebody has found important at some moment in time, right? So
yeah.
Okay, so you can start from here to find the example. I think you were looking for.
It's probably the graph builder, maybe.
Okay, so now this is an example with result, and look at the source. It's more interesting. Okay, now another thing to do here is let's read what we see in front of us. In particular, let's read what we see in the second pane here. So I'm gonna tell you how I read it, and then afterwards we're gonna try to do the same thing over and over.
Okay.
So I see an inspector because it's this gray bar, an inspector over an instance of GT example with result, which shows me a view called source that in this case shows me the source of this example. Okay, so there are a few things. First, I need to see what tool am I in. Okay, if this is an inspector, I want to know in which object at which object am I looking at. After that, I want to see what view am I looking at. Okay, now why? Because before I should look at anything, I should first know through which lens do I want to look at it. So that is the most interesting not automation. I don't know how to call it. Automatism. How do you call that? Like something that you do without thinking.
I don't know, maybe atomic transaction. Yeah. I don't know. That's a good.
So, but basically, at any given moment in time, before you interpret what's on the screen, you first need to understand, is this the thing that I want to look at in the first place? Right? So think like when you only have an editor in front of you, there's nothing to choose. So the only thing is, I'm going to think about the content has changed the shape. But here we're going to have lots and lots of different shapes to choose from for the same content. And so the shape that I'm interested in, right, it must match my specific interest at this very moment in time. And if it doesn't, the first thing I need to say, is this what I'm going to look at? If it's not, where is it the thing that I'm looking at or that I would like to look at? And then I'm going to interpret it. Never interpret it based on what I see. Always need to know what is it that I'm looking at. And then I'm going to do something. Now,
it's subtle, but that's a very different mindset, because you're right. Like in a normal tool, in a conventional tool, you would click on something and you get what you get, and then you just accept that that's the thing you're going to look at. Exactly. And yeah, you're right. This is if you view it as a language that has lots of things, you have to read what the language is telling you. I see that now. Yeah, it's a very subtle point though, because you wouldn't. I'm not used to that.
Exactly, right. And this one looks like a normal, like any other tool, and one would expect to use it like any other tool, right? And which means you say, oh, does this have this feature? It doesn't have that feature, right? But in fact, the most interesting ability of this environment is to allow you to create the feature, not what features does it come with out of the box. The feature that it has out of the box happen to be the things that we might have noticed that people are using more, but more importantly, are the things that we have found to be useful for creating the environment itself. Right? But whenever we work, for example, when we work with our customers, whenever we work on a specific problem, we're going to create the whole environments, sometimes just specific for a single problem. Okay, so always like this, especially when you look at the inspector, it can be disorientating at first, but always remember this is an inspector because it's gray. We look at which object we're looking at now, what type it has, and then what view it is. Now, if we do not understand what the view means, we can always alt-click on it. So if you alt-click on source, you're going to find here, okay, now, and this is what is another interesting thing, right? So where are we now? Maybe can you read it for me?
Okay, so we're in an inspector. We're looking at, it is a inspector on an RG method definition. So I'm not sure what RG is, but okay. It's a
method definition. What would that be?
It's describing the definition of this method, right?
Right. So it's basically an object representing a reference.
No, of this method, because I clicked on this. Sorry, I clicked on this tab. So, okay.
Exactly. Right. And this is why, right? So this was the simplest thing. Is this the best possible tool that we could possibly, like the best type of interaction? No, but it's very, very quick to build, right? And it was good enough for what we're doing, but it does require a bit of getting used to it, right? Because at first you were somewhere here or somewhere else, right? Or sometimes you're in meta, right? So if you click there, and this can get quite confusing, because now you're looking not at the implementation of this one. So think about it, right? You have a view here that shows you some source code. I want to know how this view is implemented, so I alt-click to get it there. Then I'm seeing the meta view, but the meta view shows me the implementation of the method definition itself. So now we're talking about 3 meanings of method just in this screen. So one meaning here, second meaning there, and another meaning here, which is a method about the method describing the view of this method, right? So this is another thing that is kind of important to realize. So with GT, we're thinking that the most interesting problems all relate to typically multiple levels of abstractions. So it is very important that we are able to bring those levels of abstraction into very compact, next to each other very quickly. So that because this is then afterwards what actually accelerates the ability to, our ability to actually answer questions about systems. Because when I can start, for example, I say source code and abstract syntax tree, this is what you were looking at last time, right? You want to see those next to each other. Most editors will never show you the abstract syntax tree, thereby making querying abstract syntax trees very hard. Yeah. Because it's hard to imagine what you have. Thereby, if people don't query the abstract syntax tree, they can find things because they go back to relying to strings. And so you just stripped away lots of power, just like that. Put those things next to each other, and all of a sudden you enable people, right? But of course, once you put those things next to each other, any meta programming is not trivial, and it's not necessarily intuitive. So it takes a little bit of time to get used to, right? And this is why it's so important to read where you are so that you can find your way. You can think of it like, when you're on the web, right? And then you get a phishing email, right? And you click on the link, and it looks like something, right? But it's very important that you look on the URL so that you know where you are. Because if you're not reading it properly, you're going to end up doing something wrong. And it's exactly the same thing here, except so the same idea. Okay, so we go back to the source. And so now here's the interesting thing, right? This is even called GT example with the result, right? And if I look at this one, it says GT example with result has another example inside of it, which kind of makes sense because it's an example and a result. That means it's not just a definition of the example, but I have the result, which is like a cache of it. So it kind of makes sense, right? And this is another thing that you're going to see. The source actually comes, if you, it comes usually from something underneath many times, right? Especially if I have a wrapper, things that add semantics to something. I have a core idea, a core concept, and I have some wrapper that adds some more semantics to that thing, right? I would like the thing that I have, the view that I have on my core idea, my core concept, I also want to see it in the broader one, right? And so by just looking at the method, how the method is implemented, I can reverse engineer what that means. And also I can reverse engineer how, what the wrapper means as opposed to the core. Okay. So, okay, now it's enough. Let's go back and go to where the intent was. So let's actually maybe execute this example, see what happens.
Okay, so this one.
Okay,
Right,
this
so
is one of those,
yes,
right?
okay.
And then you were looking at this BDD graph.
Yeah. Right.
And then said, right, that's what made you smile, because in the end, that's what you wanted to have on the server side, right? So that's kind of neat, because this one actually shows you, if I understand correctly, it's a representation of your older language construct.
I'll pull something up and I'll show you what it's like supposed to look like. But it's definitely it's definitely reminiscent of what I wanted to draw on the screen, what I came here to draw right on the screen. So
right. Okay.
Yeah, well, it doesn't matter. It's supposed to look a little bit different as well. So there should be two lines coming out of every one of these things.
I saw in your new representation that you have implemented in Rust. Yeah. You have it there, right? And then your idea was implement, for example, an HTTP server, serve the representation over through some, for example, a format like a dot file, and then maybe render the dot file over here, right? Right, this could be one option. The other option would be actually don't do it via the dot file, just serialize this abstract syntax tree and have an abstract syntax tree and then just interpret it here for the visualization. Because one of the interesting thing here would be if I click on V2, I want to see where the definition is. Like in your example, you had this, right now I just a dictionary. So in order to explain how that could be, let's open a playground and look at something else. Actually, not a playground. Let's browse your class here. So, for example, click on this. Yeah. Okay. If you click here, just a second, you see you have opened a coder, a class coder over this one. If you want to see it, and now by default it opens it like this. If you want to open it here, you can just press Control click or Command click, like you would on a web page.
Okay.
And then it opens it separately. Okay, good. Now let's take, I don't know, let's pick one simple example maybe, or visit row, maybe visit row. Okay, let's take a look at this one. So press on this button here. Notice that there's an inspect.
This would be inspecting this method?
This method, yes. Okay. So actually it means you're now inspecting the compiled method. So that's the actual bytecode representation. Okay, now the compiled method, to get to a compiled method from source code, you're going through a couple of stages. So first, you're going to build an abstract syntax tree. Afterwards, you're going to build the bytecode, and the compiled method is actually the bytecode. Okay, now, so you notice here that there is, for example, bytecode. And so now this is like the lowest level thing. It's just a list of things, right? Now let's try clicking on one of these bytecodes.
All right. Okay,
so first, if you now click, you just clicked once, the triangle appeared there. If you double click, you're forcing that to appear. Okay, if you once it appears, then it'll always be shown, right? But now as you move through these bytecodes, notice how you have a view of where it is. Now, how is this why does this work? Well, it works because I have now a little object which is called a symbolic bytecode, which actually comes with, with normal file that knows how to show itself. So of course it shows the source code, but because the symbolic bytecode also knows the range, so now it doesn't know it here, but if you look into, let's actually take a look quickly at how it's implemented. So if you look in the source code here, and now I'll click on it. So now we have the source code of this implementation. We see it's a text editor. We have some blah, blah, blah here. not so interesting. But here, the text, it says self-method source code. If I do self-method source code here, so if I open here Playground.
Every time I look at this, I thought it was a scroll bar, and I was trying to get it to the left and
Yes.
right. Okay, so how do I actually open? Oh, I just pull it. Okay. Okay, that's interesting.
So
I've seen you do
self-method
this, so
source code.
but when I looked at it, okay, so self
Method source code.
Okay, and then control G,
yeah.
Great.
Right, then you have the string.
Okay.
And of course, you wanted to address it with an editor and the highlighting. And of course, the highlighting already exists. I can just assemble those things. So let's alt-click again here.
Okay.
Let's alt-click again on the source code. So we have now played, we took this, we learned what it is, we play here, we replay it here just to see what does it mean? Okay, now we know. Fine. So we have that. And then it says, of course, I have a text because I don't just want to work with strings, right? So when I visual representations, it's text. And it says here, from source interval first to source interval last. Obviously, this must be this thing here. So this is how it knows the from and the to, so that I can highlight it, right? And then, of course, once I do this, I need to put an underline, glamour, blah, 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 thickness, and so on, an attribute into the text, right? So I have a text editor with this text here, and then from here to here, put this attribute. That's it.
That's cool.
But what this means now is that we could actually reverse engineer how this one actually looks like without looking at its implementation. So once I can find, so the only we've now said, so how is this symbolic bytecode working? I don't know how it is working inside, but I know that it knows how to get the source code, and I know that it knows where it is in the source code, where this specific bytecode is.
Gotcha.
And all I did was look at this representation and at its definition. So this definition actually documents how that one works. But if you look into the raw, you will see that it's actually not so trivial, because you do not see how there's no, look at the raw here, like at the instance variables of this symbolic bytecode, there is no source interval variable. So the state that is not so telling.
You have offset in bytes, yeah.
Right. So it's more machinery that happens there. But this is the most interesting thing when it comes to the relationship between the bytecode.
I should be able to click on that and see where the maybe.
Yes. So, but that's exactly it, right? Because it does all of this. So there's like a lot of things I can go on and if I want to know more. But notice how I can relate myself to this new object that you've never seen before, right? In a very short amount of time, just because somebody decided to put an intuitive view there, and I'm just going to read how the view was put together. And this is why it's also important that the views are very small, because views, the definition of these views actually acts like legends. Right? It's a description of what it is I'm saying. Remember, it's always very, very important that I understand what it is that I'm looking at, so that and only afterwards to be able to interpret it.
I definitely have a problem with that. Yeah.
It will take a little bit of time to get accustomed to, but that's why I said we don't exactly know how to communicate this. We know how to coach it. We don't yet know how to teach it at scale. And but this is where the essence is.
Well, when I've often tutored people in programming, and I've noticed that sometimes when they get an error in whatever programming language they're using, they don't really read the error. They just start immediately changing things to try and get the error to go away.
Yeah.
And I certainly recognize that problem in dealing with the source code itself, but here, because the interface itself has now become so responsive and composable, now you have that same problem with just the user the editor itself, the user interface.
Exactly.
That's interesting.
Precisely.
Okay.
And so now imagine sometimes every once in a while, it's possible that the view has a bug,
Mm.
and it misleads you into thinking something. So this is why it's so important to be able to navigate these meta levels quickly. It doesn't take long, because that's why the language is important. It's the same thing as with the errors, right? It's like once you know how to handle or to think about errors in general, you're going to be able to deal with lots and different kinds of errors that you find in practice. Same thing happens here. So this is a reusable. It's the same flow over and over again, which is in fact the most interesting thing that probably we've produced, is the fact that for every single problem that we're facing, we're going to follow exactly the same flow over and over and over again, and which is basically the validation. So the reason, GT itself is a validation of multiple development, because we're building it following multiple development, and it's an elaborate system, but it's built with no external funding, basically. So the only funding we get is the problems that we actually solve with it. So only if we are significantly, let's say, if the results that we produce are significantly better than what the expectation is from us. For example, you mentioned last time, you summarized how in our work that we work with companies that have legacy systems, and we help them find their way out of them. That's one thing we do, but the other one is actually work with companies that are seeking competitive advantage. So if we say it's correct, if multiple development does lead to a significant productivity increase, then it's also worthwhile to invest in it and be early. So there are a few of these that are willing to do that, and so interesting enough, those that are interesting to do this are also very good themselves. So being able to improve on what the good team does is not a trivial thing. So we only get funding if we're able to do those kinds of, to get people to new results that otherwise they wouldn't. And so we don't promise anything. We don't sell on a promise. We actually have to solve problems.
Right. It's funny. So K3 language is the language I use at work, and I was actually I don't have any idea how far I got with this, or even, but the intent was to write a parser for this unusual language that doesn't have a lot of tool support, and
nice.
And start inspecting some of our source code, because we have it's a 20-year-old system, and some of it's been handed from person to person.
Nice.
I was very interested in that. So. I have no idea, but I don't want to derail the conversation here, but that was kind of.
But that is absolutely a use case. So for certain, right? So I just wanted to show here, like if you look at the representation that you had with your tree, right, which is some low level or the underlying representation of the language. If you look at the examples,
I was looking at this. I was looking at.
Just looking at the examples inside the repository, or there, both are possible, right? Just different meanings, right? This one is examples inside this package, and these are examples inside this repository. A repository might have multiple packages, for example.
Yeah, so I feel like I kind of because I have so many things in here, I feel like I'm polluting the namespace, and that's why earlier I removed some of the packages.
Right? Yeah,
or not polluting the namespace, but there's too much clutter here now. I guess too hard to see.
But that's why it's important. Precisely, right? And this is why it's important to know. Okay, so in order to find this, what's the scope that I want to search in? It is not just the search that is important, but also the scope in which I'm going to apply the search as an operator. That is important, right? So that thing, when you click on the node, ideally you want to see it. Oh, here it is in the original source code. Because, of course, in your case, you only have actually a dictionary. You don't have source code, right? Your source code was the input to the graph build. There was a dictionary,
right?
So this is probably the best you can do in this specific situation. I was just saying that it can be more than that. If you go back again to this to our tab. Right. There is you can scroll here to the right, and by doing it, just to shift and vertical scroll, Yeah, and then you have tree.
Oh, it's shifted. Okay. So tree.
So this is now going to be the abstract syntax tree. So click on this, right? So this one is not just a list, it's a tree. So in your case, it's a graph. In this case, it's a tree. And then again, you'll see the source code here.
Okay. I'm a little, I'm not entirely sure. I haven't caught up with like what I'm looking at here. This is, all right, let me do what you said. So I'm looking at an inspector for a compiled method called visit row in. So this is my visit row method, which is this source code. Okay. So I'm looking at this IX token right here. Okay. Oh, I see it now. Now I can see it on this side. Okay, got it.
So this is your abstract syntax tree of the Pharo method.
Yeah.
And this is the tree that you can, if you want, you can query against. This is the tree on top of which you can perform refactoring. You can even program refactorings if you want to. But it's very important to know, oh, what is it underneath my method that I'm looking at so that I can actually apply these meta level concept, manipulations on them, right? And that's why right here, we were looking at a specific method. Interestingly enough, the method was about defining the source of in another language, right? And then there I'm saying, actually, well, I want to see how the method is implemented inside. So one step next, I'm now jumped the meta levels. And then in there, I chose the view. Not only that it shows me the compiled method, but it shows me the abstract syntax tree, which is another step from the source code towards the compilation part, right? And so this is, but the interesting thing is how do you use these views afterwards? Like, because the views that exist are interesting because they document some questions that some recurrent questions that people had before. But it's actually the more interesting part is the views that you're going to create for the questions that you're going to have, for which probably there will not be ready-made answers. Okay, that's the difference in because this is a new way of programming. That's why we are saying it's a new way of programming, because you're going to think about something else. Interestingly enough, it will lead to interesting new properties. And so that was that. Now there's at least one point that I would like to get you through. I think you had a question about Mondrian, so the visual part, but I wanted to show you a little bit about the algorithms, because you expressed this. How do you explain an algorithm?
Okay.
So so go here in the main tab in the book. In the book, and there's a couple of case studies, and I think those are interesting. Now for you, as I said, Glamorous Toolkit itself is a case study. So there are all sorts of interesting things. Wait here.
Oh,
this is Glamorous Toolkit as a case study. Yeah, go a little bit down here. So you see here, okay, look, there are 2,656 views, custom views.
Yeah.
Right, and a few hundreds of other kinds of extensions. Okay, so here, for example, there is this explaining the scorified tree map algorithm. It's just an example. So a tree map is this draws that, right? You have a tree and you have some a tree map representation. Scroll a little bit down, not much. Okay, so actually our implementation comes from this paper from 2000. And if you scroll one more picture down, actually this paper, the gist of it is represented in this picture over here, which is like, you know, those steps that you're interested in when you're saying, this is how this algorithm works. It means I'm going to try to put it here, and then the second one, I'm going to try to put it here. The fourth one, I'm going to put it, the third one here, but then this doesn't work. So I'm going to backtrack and I'm going to put it here and so on. Okay, so you have this one. Now, so when we produce the output, right? The output is interesting, but this presentation here, that is the documentation of how the author of the algorithm thought about the algorithm. And this is the presentation that we found interesting when we have implemented the algorithm. Therefore, it's very important that the systems carries exactly this one forward. Not only the result is important, but exactly this step. So if you scroll now more, you find precisely that. Okay, now let's go a little bit down, because you have here the actual an actual inspector, right? And you see here it's an inspector over a GT graph tree map Squarify, and it has a couple of views. One is a preview, right? But the other one is with the steps that it took, and this one is a different representation of this one with more information about so this is the visual one, which works in small scale. But if I have a large scale, I want to find some problem on the 1,000 step, that's not the most appropriate kind of representation. So the steps list is more interesting for that.
If I click on this, okay, so you all steps preview, and then you just, okay, so I don't have to play this. I don't want to, again, derail the conversation. This is awesome.
No. Yeah. No, I thought that this was something that you want to look at. So let's take a look at, for example, the step list, or just click here. Let's see if, yes, exactly. So if you clicked on this, you now get here one of the steps. And one of the steps knows how to present itself. This here is an assembly of these pictures from the right for all of the steps. That's it. So, but now what this means is that sometimes it means that in order for me to inspect a step must be reified, must be first class. If I make the step first class, I can inspect it. But it's actually possible to implement this algorithm just like a function without an intermediate representable state.
Sure.
Most people will implement, most people. So if you just look, for example, from a test-driven development perspective, or most people think about systems in terms of here's the input, here's the output. Right? From that perspective, it doesn't matter how it is implemented inside. But there is a great deal of value that actually is encoded in how the system does what it does. And you, for example, right? So in your case, you want to teach people. And therefore, it's important to describe how, what is the actual steps that you will take. But what we find is actually that by just having the need to visualize helps us discover design in a way that a functional decomposition doesn't.
Well, that thing that I was showing before is exactly this kind of thing. I was printing out one line of text for every step in my algorithm and trying to visualize that, but I didn't take the step of actually making it an object that you could
exactly, because there was no push. And that's we think that this is the most interesting part of the feedback loop in moldable development. That is, you just let the artifact drive. It's just a very simple artifact. I just want to draw it. Once you want to draw it, you say, well, what do I put the drawing? And therefore, I need arise to create this thing needs to be first class, because otherwise I don't have a place to put it. Once you put it there, it needs to have enough information to draw itself. Once you can do this, you move on to the next step and the next step and the next step. And in the end, what you end up with, and now let's go back to our document here. What is this document? Right? This document is not a bunch of pictures. This document is actually live. Yeah. So the act of programming produces the explanation as a side effect. So that's why the environment plays such an interesting role. And that's why we have integrated, for us, there's no distinction between knowledge management, programming, data science, all of these things, working with APIs, they are not verticals. This is exactly one and the same. Right? And that's why you can start combining them in arbitrary forms.
That's very interesting.
Right? So here, what you're seeing here, this one here, is actually, right, if you just scroll a bit more down, you will see it actually comes from, there.
Sorry?
Up, more up. Okay, here, stop.
Okay.
Okay, here, right here at the bottom of it.
Oh, this?
Yeah, just a little bit more down if you scroll. Yes, there it is. This is a snippet of an example. If you hover over it, right, you notice that this is a GT example. which is, it comes from here. If you browse it, this is the example that we wrote to test the functional one, right? But when I take the example plus the fact that it gives me an object back, and then on that object I have a view, I get to create the documentation.
This is very, very cool.
So, which means that, because our goal was to say, in order for this to work, it has to be applicable everywhere. It means it must exist. It must be a unifying flow, not it works for these kinds of problems, but not for these other kinds of problems. Because if it works for this kind of problem, not for the other ones, it means that there's going to be a very large set of problems for which it will not work, which means that it will not bring anything meaningful in terms of productivity. But we find that, and if you look at the list of case studies, you will find that basically we pick them so that they're literally considered verticals. Maybe in each of those kinds of verticals, you might find, billion-dollar company selling dedicated technology just for that.
Yeah.
And it's a wrong way of thinking about, it's a wrong way of thinking about, we think it's a wrong way of thinking about tools in general, right? So there's a much simpler way. So I wanted to give you just the vocabulary. First is understanding, like describing the tool that you have in front of you. First, to know where you are, and then you want to know, what do I really want to see? And then you're going to search for the thing that you want to see, and you say, do I have it? And if I don't have it, and if I don't have it, I'm going to build it, or I could create it, which is the interesting skill to look at next. The other thing is, simply by creating these kinds of views, we find that it actually guides design and enables explainability from the inside out, which goes hand in hand with your intent to explain algorithms and data structures to others, right? So from this perspective, what we still have left open as a subject is, how do you draw? You will find that actually, you started playing with Mondrian, but this is not Mondrian here. Mondrian actually happens to be just a tiny library now. On top of this, everything you see here is already a visualization engine. So, like if you look on the web, right, you're used to the idea, oh, I have the HTML, and if I want to visualize, there's a special thing that comes in the middle of the page where the visualization would be. Right? But here you're not. You're already in a visualization engine. There is exactly one single rendering tree for everything. And,
I've heard you say that, but now I'm kind of seeing it in a different light. Like you're saying like you didn't like sit down and write a visualization for this. You had these visualizations because you made a little visualization over here and a little visualization over here. And then you just put like, okay, now just draw them in a table.
That's one. But the other thing is that this one and this step here and this text inside an editor, they are all literally in the same rendering tree.
Yeah.
They're made out of the same things, which means that you can combine anything with anything. So you're not just, when you're drawing visualization, you're not just bounded by, just some text and boxes and so. You can actually have full-fledged editors, any complication you want, in any shape you want, anywhere on the scene inside the graph, for example, because there's no difference between those. So it would be interesting to maybe to have a follow-up in which we can just take a look at those. Maybe on that occasion, we can take maybe one example of an algorithm to try to explain it to some extent, or just take a few first steps towards there.
Yeah, I'd love to come back, and I definitely have a lot of more. Yesterday, or 4 days ago, I was looking at this from a very surface level, and even then, it was like really really impressive to me, and I saw a lot of value in it. But now I see there's I'm seeing a lot more depth to just to the system itself, and I don't know, I'm inspired now to to go make something. So yeah, I would definitely like to come back and maybe bring an attempt at an algorithm that I've tried to explain, and maybe get your thoughts on that. And
Perfect.
yeah, this is awesome. Thank you so much for the tour here. This is
Well, I'm
more
glad
than a
it was
tour.
useful.
Very useful.
I'm glad it was, and I'm glad it was useful, and well, also thank you for the interest. This is all of these things are not obvious, and we're looking for people that are more, let's say, inclined to look into this way of thinking, because it's a different way of thinking, and like any new way of thinking, it might or might not, create value. What we believe that this is, we're very early in what is possible in terms of explaining the inside of a system, but then afterwards in terms of exploiting the opportunity of that comes once a system that used to be a black box, expensive to think about, actually makes you smile, because it's you can answer questions faster than you type them on ChatGPT. So yeah, and that's it's an actually interesting challenge, in fact. And but so I think that there's a lot that can be done in this space, and we're looking for people that are interested to explore it with us. So thank you for that.
Oh yeah, just a thought I had along those lines was, you're welcome. But I in my videos I tend to use a really obscure language called J, which is it's an array language, kind of in the APL family, and you type 1 or 2 characters and you get a lot of stuff on the screen. And
right,
like small talk in general, so just small talk by itself, it probably does not give you that kind of compactness. But what I was thinking about with this is that, like, here, you've got that kind of, I guess I'm talking about the ratio of like the number of input characters you have to type, or actions you have to do to get like a big result on the screen. Whereas here, maybe it's not small talk itself, but Glamorous allows you to do, like, have one click and have a giant diagram appear on the screen, and all kinds of things like that. And it's not just, oh, I made a presentation where that one click triggers this. It's like, that's the actual thing that you can download, and you can click somewhere else, and you can get a new diagram that does what shows what you want to see. That's what's fascinating. You've got like a massive return on investment per like button press,
Precisely.
So yeah.
And the other thing to keep in mind is that these pictures that you see here, these are not demos. These are not tutorials for other people. These are things that we have created out of engineering needs. And that's the other thing that is not so obvious, right? In places, people think, oh, for newcomers, we need certain kinds of explanations. For the people that already know how to program, we need other things. And that's we think that that's not entirely correct, because there's this continuum that, in order for this to work, you have to serve everybody at every level of in the continuum between not knowing anything and knowing everything.
Well,
right?
Test first design became like a big thing and people started, it was kind of like controversial at the time. Like, why would you ever write a test before you write it? Like, test comes after, in the traditional point of view. And here you're talking about like documentation and visualization first, right?
Yes.
Build.
Yes, this is why we're saying this is so test-driven development introduced a feedback loop. And it's, the interesting thing about the feedback loop is that you don't evaluate it at the first level. That is, here's what I see. You usually evaluate it at the second, third, fourth orders of effects. So, for example, an interesting thing of a side effect in test-driven development is the fact that it guides design, right? But that's not an obvious thing, because people say, oh, it's about testing. But yes, it is also about testing, but it has these other interesting side effects, which are not obvious at first, like DevOps, right, or continuous delivery, introduce another feedback loop, right? So, but there is the interesting thing to look at it is not at the technical level, but it's interesting to look at it how if the organization now changes so that it stops deploying features, but start deploying experiments many times per day, except that features one time per year, then you have a whole new, market opportunity. So the business changes completely. Just out of a tiny change on a technical level, the whole thing changed completely. Now, I call the conversation with continuous delivery, it's an outside in type of conversation, because basically it's to me the most interesting effect there is that you have the platform, you have a way to orchestrate a conversation. You say, here's my experiment, I'm going to deploy it in the environment and see and learn about how the environment reacts to it. Right? And the faster I can do it, the more I can learn, the better I can find an opportunity. Right? So it's outside in. I learn from the environment and then I internalize into the system. What we do, multiple development, we believe it introduces another feedback loop that complements the other ones. But in this case, it's an inside out type of conversation. There are opportunities that only exist inside the system that are not visible from the outside. And once you start to exploit those on a business level, then it becomes really interesting. Because in the end, all decisions that you see today in a software related company are primarily about decisions about the software system. But those decisions should be informed by the current state of the system, and not only about the wishes about the future. So understanding and having, understanding how the current state of the system is right now at basically zero cost, completely changes the equation, because that's basically what occupies the largest effort today. So people basically make decisions when the time is up, not when they are certain. And that's why you see all these problems when you have large, for example, I don't know, migration development projects and so on, where people are doing, and after 2 years of effort, nothing has moved.
Yeah.
And so there's this problem. So what you're seeing here, this tiny case study with the square environment, this is not our attempt to explain something. This is literally the debugging tool that we have built so that we can think. Right? This is a normal byproduct of work. It's not a different world. And that's what I would be interested to actually explore with you, right? So yes, let's teach newcomers, but can we teach newcomers about anything in the software system? So thank you very much. And let's do follow up.
Yeah, thank you so much. This was wonderful. I very appreciate it. Yeah.
Thank you.
Mm-hmm.